Hello everyone. So in the previous part of the discussion, we had arrived at this specific form of the relation between the stresses and the strains through this elasticity tensor, this fourth order elasticity tensor. And at the end of that discussion, I had mentioned that we would be discussing certain ways of simplifying this relationship. So uh, first of all, we note that this fourth order elasticity tensor Cijkl, uh, how many independent constants does it have? Okay, so I say independent constants because please note that we are working under the assumption of uniformity or homogeneity. So different parts of the material of a body would have the same value. Okay, so in that sense, it's a constant. So now we have these uh, these four indices in the subscript. So this indicates that because each of these indices go over three numbers 1, 2, 3, so in total we'll have 3 into 3 into 3 into 3. So in total 81. Okay, 81 different elements or 81 different components of this fourth order tensor, and that is true for any fourth order tensor. Okay, so the first thing would be to try to simplify to a situation where these 81 different, apparently different components can be reduced in number based on certain physical considerations. Okay, based on what you have studied in the previous chapters. So towards that end, we'll go to the next page and start our discussion of a new topic called minor symmetries. All right. So we'll again consider this relation sigma ij is equal to uh, the ij kl epsilon kl. Now what we'll do is we'll simply interchange the I and j. No harm done. Okay, we interchange. We'll see what is the motivation behind that. We interchange I and j. Okay, so instead of doing this, we might as well have done that we set I equal to p, and or we change I to p and j to q. Similarly, on the right hand side, we would have changed I to p and j to q. No harm done. In a similar fashion, we just interchange I and j. Whatever the information is captured in this relation, that remains undisturbed. So what we have here is sigma ji is equal to the ji kl, and this remains unchanged. Now, if we subtract this relation from this relation, what do you think will happen? You please, so let's do that actually. So suppose suppose we name this one as hash 1, this number as hash 1, and this number as hash 2. What we want to do is hash 1 minus hash 2. Okay, so that will give us sigma ij minus sigma ji is equal to the ij kl minus the ji kl bracket epsilon kl. But we already know from the symmetricity of the stress tensor that sigma ij is equal to sigma ji. Therefore, okay, so what we have is 0 is equal to C ij kl minus C ji kl epsilon kl. Now in general, none of the components of this strain tensor epsilon kl is going to be 0. So in general, that's what is going to happen. In general, none of the strain components we expect to be 0. So the only possibility for this relation to be true is that C ij kl must be equal to C ji kl. Okay, So basically, it does not make any difference if we interchange the first two indices of the elasticity tensor. Okay, so this is only one of the first or one of the minor symmetries. Next, what we are going to do is interchange K and L. So again, we have sigma ij, so that remains undisturbed this time. But on the right hand side, we have Cij Lk and epsilon Lk. We number this as hash 3, and when we do a hash 1 minus hash 3, on the left hand side we have 0, and on the right hand side we have Cij Kl minus Cij Lk. Sorry, I should not be writing like this right away. I'll make this correction. So this is epsilon Kl minus Cij Lk epsilon Lk. But we know that epsilon Kl is equal to epsilon Lk, okay, from the symmetricity of the strain tensor. So what we'll have is 0 is equal to Cij Kl minus Cij Lk multiplied either by epsilon Kl or epsilon Lk, doesn't make any difference. And again, the argument is that since the components of the strain tensor are not going to be 0 in general, therefore we can conclude that Cij Kl is going to be equal to Cij Lk. So these two things that we have just obtained, let me go to the next page and number this page. So just now what we have obtained, that the Kl is equal to Cj Kl, and the Ij Kl is equal to Cij Lk. These two pieces of information, they are together referred to as the minor symmetries of the elasticity tensor. Okay, minor symmetries of the elasticity tensor Cij here. Okay, now what the benefit of these minor symmetries is that the relations, the sigma ij equal to Cij Kl epsilon Kl, that relation which is apparently captured by these what was originally these, if we go back, these 81 constants, we can actually realize that this has been significantly reduced. So this apparently 81 independent components, this number has been actually reduced. So let's see how it has happened. So here, when we are talking about this, see the interchangeability of the ij, the first two indices. So as a result of this, what we can conclude from here is that instead of the 3 into 3 into 3 into 3, what we really have is 3 into 2 into 3 into 3. The 3 into 2 is happening because the ij, the interchangeability of ij tells us that this is basically a combination and not a permutation. Okay, so suppose you had I equal to 1 here and j equal to 2 here, so it is exactly the same thing as 2 here and 1 here. Okay, so if it had been true that 1 2 is not the same thing as 2 1 here, then that would have been a permutation. But here we have 1 2 sitting here, 1 2 kl, let's say, is the same thing as C21 KL, whatever the K and L may be. So it's basically that interchangeability tells us that this is a combination. So we have this kind of a thing here. All right. Furthermore, if we go to the next one here, so this is basically telling us that already we are having this 3 into 2. Now again, the interchangeability between K and L is telling us that those two positions are or the indices sitting on those two positions are no longer like a permutation, instead they are like combination. So what we have here is 3 into 2 again. So if we just take stock of here, at this place what we had was 3 into 2 6, 3 into 3 9, so it's 54 constants here. So from 81 constants we have reduced it to 54 constants at this stage, and here we have further reduced it to 3 into 2 6, 3 into 2 6 equal to 36 constants. Okay, we don't need to write this, 36 constants. Okay, so from 81 it has been considerably reduced to 36 constants. All right, so this is the major benefit of the minor symmetries. Now what this minor symmetry also gives us as an added benefit, that we have actually obtained these 36 different values, is that the way that we can represent on a piece of paper or on the screen how the relationship between the sigma tensor and the epsilon tensor can be written, that can be considerably signified, and that we'll see in the next part of the lecture. So through something called the Voigt notation, which will actually also help us to answer one question which some of you have been asking me since the chapter on mathematical preliminaries. Okay, so we'll see how that goes about. All right, thank you.